my name is Kyle Beckert, and today I'm here to talk to you about mitigating riser gas unloading risks through dynamic wellbore simulation, alongside with Heurtin, Connor Stang, and Quinn. For our project outline, we have an executive summary to start off with, and it goes to a background study with the motivations behind the project as well as its objectives, the methodology of our project, the budget, economics, and the health, safety, and environmental issues associated with it, and as well as the expected deliverables of this project with a timeline given. Next, Quinn is going to talk to you about the executive summary and the background study.
Ready?
Yes. So the introduction associated with our project is looking at the risk associated with riser gas rapid unloading if gas is not removed properly. And this is especially challenging for oil-based muds in which the gas is dissolved in solution. And the objective of our project is looking to simulation software to examine mitigations to riser gas unloading and coming up with a simulation model which we will test with this case study and then perform sensitivity analyses of parameters of interest. So the summary consists of looking to the risk of riser gas rapid unloading, which consists of well control issues, looking to mitigations to these risks, which consists of managed pressure drilling and using surface back pressure, especially for oil-based muds in which the gas is dissolved in solution, and then using lower circulating pressures, especially when the gas is approaching surface. And then the benefits of these mitigations are that the water hammer effect is almost negligible when you close the riser faster. In addition to using surface back pressure and lower rates can help handle the gas better as it approaches surface. So the background study consists of this article by Quinn et al., which we examine and which we will replicate in our study, which consisted of them looking at dynamic multi-phase flow software similar to what we'll be using, Schlumberger Olga, investigating riser unloading, and they investigated shut-in time and back pressure procedures as mitigations to riser gas unloading, and then they investigated relationships between standpipe pressure and liquid rate versus time. And they discovered that shutting in the riser in a short time frame, about 10 seconds, resulting in a small kick, will result in almost no water hammer effects, resulting in high pressures. In addition, using surface back pressures and lower circulating rates can help handle gas coming out of solution in oil-based muds. And then, as a result, water-based muds are much safer than oil-based muds in offshore drilling. So with that, I will turn it over to Connor Stang, who will present the project motivation and objectives.
So now we're going to go over a few of the motivations behind our project. Obviously, with rapid expansion of undetected gas in the riser, this can pose a significant threat to both rig personnel and equipment. So uncontrolled situations, like in the form of blowouts, may happen and result in a loss of life. So procedures for mitigating the risk of riser gas have been continually researched, but have still had the potential to be optimized further for more reliability and safety. Dynamic wellbore simulators, like Schlumberger Olga, can be used to study the behavior of riser gas migration and test various procedures for handling it. Field simulations have been performed in the past, but can be used for comparison with simulated results to determine the viability of using drilling software models. We can then use further modeling to support data and be able to optimize better procedures for mitigating riser gas. So our project has a few objectives. The main focus is to utilize dynamic wellbore functions in Schlumberger Olga software to simulate unloading of riser gas. We can then determine field procedures for optimizing the mitigation of gas unloading. And we will do this 4 different ways. First, we will determine the viability of simulation results by measuring standpipe pressure trends and maximum fluid velocity and comparing them to previous field simulations. This will be performed for both water-based muds and oil-based muds. Just as Quinn was referring to earlier, they do have different properties, and will act differently, or we are expecting them to act differently in the riser. Our second aspect will be we will apply various surface back pressures in the simulator to analyze the effectiveness of both riser gas handling and managed pressure drilling systems, as those are the two most common mitigation procedures used today. Third aspect, we will determine the effects of water hammer on surface equipment when closing the riser. When closing the riser, the water hammer can pose a threat to surface equipment by increasing pressures very rapidly. So to see how the water hammer affects this equipment, we will vary the riser closing times in the simulator. We will vary the volumes of gas present in the riser, and we will measure the surface pressures applied to the surface equipment to see if it can be handled. And the fourth aspect will be to provide a simulation of riser gas migration during dual gradient drilling operations to be used for further study, as dual gradient drilling is one of the most commonly used methods nowadays in offshore drilling, as the mud windows are getting continually smaller and smaller as wells are having to be drilled deeper offshore. Four aspects that I just mentioned. We developed a system of goals to achieve all four of those, and each one of these is relatively independent of one another, and we'll have multiple team members working on each simultaneously. They mainly involve input of data, running the simulator, performing an analysis of what we're trying to achieve, and then making technical write-ups of all of our results to be presented at the industry panel. And now I will turn it over to Stephen to go over project methodology and the budget.
Alright, so as Connor said, I'm going to talk a little bit about the methodology of our project and how we're going to perform the actual simulation. So first things first, we're going to use the Olga software from Schlumberger, which provides a dynamic simulation of time-dependent parameters in multi-phase flow with respect to time. We're going to acquire some data from the paper that we reviewed originally, and if we need more, we're going to try and contact the person, the actual author of the paper, and hopefully get the rest of the data should that be needed. Some parameters we're going to measure are the pressure variations such as standpipe pressure and surface pressure that occur as the gas is expanding in the riser, as well as the liquid and gas rates at the surface. And we're going to do all of these with respect to oil-based muds and water-based muds to see how each one reacts differently when the gas is expanding. And there's also going to be other parameters that we're going to measure too that aren't listed on this slide of the PowerPoint. So we're going to put the data that we put in is going to give us plots between all of these, and we're going to use those plots to give us to perform an analysis and interpret all these results and figure out what the best operation procedures are to mitigate the risk associated with riser unloading. And as per Dr. Chen, we use this software as a means of performing a sensitivity analysis for various parameters so we can optimize procedures that we are going to be trying to mitigate. So next is the budget, which we've recently found out that the soonest training for the Olga software from Schlumberger themselves in Houston is actually in February, which by the time we do it would be too late because then we wouldn't have much time to perform the actual simulations and interpret everything. So we're going to try and get them to perform a training session here at LSU, which is going to cost around $1,000, which is a rough estimate at this point. And hopefully it won't be just our group, but it will be other groups that may need some little software or just have an interest in this software. And next I'm going to turn it over to Kyle to talk about the economics and the HSE surrounding our project.
So I talked briefly about the economics. Unloading events can cause operators extra expenditures. Fluids are intangible costs, but with the rapid unloading events occurring, that requires them to make up and build up more. And with this table, you can see at different amounts of the different amounts of volumes that come out increase the cost, obviously. And as well, with this, riser gas mitigation techniques can lead to routine well control practices, and that results in saved lives, protected marine environments, and revenue gained because you're not losing that fluid as well as you're protecting your equipment and keeping your rig operating. For the health, safety, and environment, rapid unloading events do cause loss of life, damage to the equipment, and can cause severe environmental threats to marine environments if injections occur. And to help mitigate these risks, we have back pressure applications, and that greatly reduces the unloading risk for kicks that are less than 5 barrels for the gas expansion effects. And we also use MPD systems as well as rapid choke closure, and these mitigations really help keep both your equipment safe, the people, and the environment overall a lot more safe. And for the deliverables, we have a timeline that goes over it, and this just discusses all of our rules, all of our tasks, and the overall team's goals and tasks, and when we expect to get them done by, and it will keep us in line and keep us moving forward with a good structured plan. Thank you.